Welcome students. We want to discuss about triple integral in spherical coordinates. So first, let's try to understand what does it mean by spherical coordinates. So take a point P in the space XYZ space. To this point, we'll associate three numbers, rho, theta, and phi as the coordinates. So rho is take the origin and take distance of P from the origin. We call that distance to be rho. Now, when you join O and P, you get a line segment OP, and you look at the angle made by positive direction of Z axis, you call that as phi. And then you take this point P and you project it down to XY plane. So the point will be P prime XY0. This projection OP prime makes an angle of theta with X axis that would be called as theta coordinate. So these are the three coordinates uh, in the for the spherical coordinate system. So the reason why this is called spherical coordinate is, first of all, rho equals to a. What does it mean by rho equals to a? So rho equals to a means you're looking at all the points from the origin, which basically are distance a from 0, 0, 0, or the origin, and you get a sphere. Okay. So rho equals to a, one of the coordinate uh, surface, coordinate plane actually, but the plane here is a surface. So rho represents a sphere. So hence we call this as coordinate, hence we call this coordinates as spherical coordinates. Let's understand a little bit more about this. One way to understand that would be to see how does rho theta phi, the spherical coordinate, relate with the Cartesian coordinate. So, so let's look at that. So if we have point rho theta phi, x coordinate, so let's work on z coordinate first. So z coordinate is this length here. Take this triangle now. This triangle is a right angle triangle. And so we'll use trigonometry in that triangle now. So the right angle is here. So that means the hypotenuse is going to be this side. Let's see what is cos of phi. Cos of phi is going to be adjacent side, which is z, over hypotenuse, which is rho. And sine of phi is pq, opposite side, divided by rho. But note that this is a rectangle, so pq equals to op prime over rho, which is same as r over rho. So in this case, first of all, you get directly z equals to rho cos phi. And here we get r equals to rho sine phi. Rho sine phi equals to r. Now we are in this plane. So in this angle, if this angle is theta, we can use the polar coordinate in this region, right? So polar coordinate tells us x equals to r cos theta, which is r is same as rho sine phi cos theta, and y will be r sine theta. R is the rho sine phi sine theta. So these are your conversion from your spherical coordinates to Cartesian coordinate, which is recorded here. All right, so note that in there is a cylindrical coordinate. The connection is, if you have in cylindrical coordinate, you had x equals to r cos theta, y equals to r sin theta, z was z, and in this case you are just replacing r equals to rho sine phi, right? That's what you're doing, and your z is rho cos phi. Okay, right. So now let's try to see how do coordinate planes in spherical coordinate look like. Now note that what was the coordinate plane in xy axis. So if you took x equals to 0, it was basically, if you took x equals to 0, it gave us basically yz plane, right? It gave us this plane here, right? In the Cartesian coordinate system. Now let's see what does rho equals to for spherical coordinate system. So what do we get? Rho equals to c. That means the distance from the origin is fixed c. Okay. So rho equals to c would be a sphere of radius c, right? Because all the points on this sphere are at distance. All the points on this sphere are distance c from the origin. Of course, we are assuming c is positive. Now, how will theta equals to c look like? So in this case, this is our xy plane, x, y, and z. So theta equals to c. So all these points here, so if this angle was c angle, then theta equals to c will look like this half plane, theta equals to c, right? So this plane, half plane, will give me theta equals to c. Now what about rho equals to phi? So again, let's look at the coordinate plane. So phi equals to c basically is you make phi with the positive direction of x-axis. So you're collecting all of them, which make phi with the positive direction of z-axis. Sorry. So we get a cone. So all these, if we think about rulings on the cone, all these make angle of phi from the positive direction of z-axis. So these are the coordinate planes in the spherical coordinate system. So if you think about it, if you have these kind of geometric objects, they are easy to represent in the spherical coordinate setup. Okay, so now let's look at few examples now. So a rectangular coordinate. So find rectangular coordinates of point which has spherical coordinate 2, pi by 2, pi by 2. So again, x is rho. So this is rho. Then we have theta, and then we have phi. Okay, this is the convention we are following. In the representation, we write rho theta phi. All right. I mean, some can have convention of writing rho phi theta or in the order, but for us, we are following that convention for writing things. Okay, so x is going to be rho sine phi cos theta. Y is going to be rho sine phi sine theta. And z equals to rho cos phi. Now, you know that cos of pi by 4 is 1 by root 2. So we get 2 times 1 by root 2 times 1 by root 2, which is going to be 1. Similarly, you can see y is also 1, and this will be 2 times 1 by root 2, which is root 2. So the xy coordinate, so x, y, z, the Cartesian coordinate is given by 1, 1, root 2. So now look at the next problem. Find the spherical coordinates of this point, whose rectangular coordinates are given by -1, 1, 1. So first we'll compute rho. Rho is going to be square root of x square plus y square plus z square, which is square root of 1 square plus 1 square plus 1 square, which is going to be root 3. We can write the many ways to find cos phi. One way would be to find cos phi is z over rho. This is going to be z is 1, rho is root 3. So we get z is 1, rho is root 3. So we get phi equals to cos inverse of 1 by root 3. And then we have cos theta equals to x over r, which is rho sine phi. So, or we can write now in terms of, so we got y equals to, let's do that. We get y equals to, because we already have cos phi, right? So we have y equals to rho sine, but we have cos phi here. So we have y equals to rho sine phi cos of sine of phi. So we get, what is r? So x r equals to rho rho sine phi, and in that case we have rho sine phi, and we get, so I was thinking about going through rho sine phi, but I mean we can ease the mechanism by basically projecting it down to the xy plane. So we have xy plane, and this is where our -1 1 lies. So if this is -1 comma 1, then we get theta equals to tan inverse of -1, which is going to be minus pi by 4, or in other words, it could be 3 pi by 4. Okay, so this is theta, phi, and rho. Okay. Now let's look at the cylindrical coordinate of this equation. So we have a sphere x squared plus y squared plus z squared equals to a square. So let's see. So we have cylindrical coordinate was essentially x equals to r cos theta, y equals to r sine theta, and z is z. So we get x squared plus y squared becomes r squared plus z squared equals to a squared. Yeah. So it's like a circle. The sphere looks like a circle in the cylindrical coordinate in RZ plane. What is the equation of a spherical coordinate of sphere? In this, we get rho. So x squared plus y squared plus z squared. We already saw the connection is that x squared plus y squared plus z squared, x squared plus y squared plus z squared equals to rho square. And of course, this is tan phi is also r by z. So we get, here we get rho square equals to a square, or if you're taking rho to be positive, we get rho equals to a. Yeah. So this is the equation of your sphere in the spherical coordinate. So it's basically a coordinate plane. Very nice, beautiful representation. Now sketch the solid whose inequalities in the spherical coordinate are given by 0 less than equal to phi less than equal to pi by 3, and rho is less than equal to 2. So rho less than equal to 2 represents a sphere, filled in sphere of radius 2. So rho less than equal to 2 represents the sphere. However, phi, which is the angle made with the positive direction of z-axis, that is pi by 3. So no matter what, it's going to be the angle. If you join all these points and take a segment OP, all these lines have angle positive direction, angle with the positive direction of z-axis as pi by 3. So it's essentially a cone. So the solid is essentially this fixed, this filled in cone. Okay, so this is your solid. Okay. So now we want to discuss about what is the volume element in the spherical coordinates. So note that we had for x, y, z. So this was for Cartesian coordinate. We had dv is dx, dy, dz. For cylindrical, we had dv was r, dr, d theta, dz. Okay, so we want to have a similar notion for spherical coordinate system. So note the following. So let this be a spherical wedge. So you cut a spherical wedge. Now you want to basically, so this is a spherical wedge. So you can think about this as a rectangle. So your spherical wedge, you can think about it as a spherical rectangle. So one of the sides of this can be seen as rho sine phi d phi. The bottom can be seen as rho d phi, and then this side can be seen as d phi. So when you multiply them out, you get d rho times phi d rho d phi times rho sine phi d theta. So this becomes rho square d rho d phi d theta, or any permutation of this, right? So this is your volume element. In fact, the triple coordinate, if you want to integrate triple coordinate, you want to do a triple integration in spherical coordinate, you replace x by rho sine theta cos phi, y by rho sine phi sine theta, z by rho cos theta. Your dv gets replaced by this volume element, which is rho square sine phi d rho d phi d theta, and u is representation of rho, phi, and theta, appropriate to describe the space E in the spherical coordinate system. Now with the triple integral, again, as with the Cartesian triple integral or with the cylindrical triple integral, when we are trying to do the triple integration in spherical coordinates, we still have to answer the same questions, same set of questions. First of all, we need to find out what first, whether we do integration with respect to rho, theta, or phi first. So that we can do by basically looking at the footprint of the proposed integral. Then we want to look at the bottom and top surface. We want to look at the side surface, and we want to see how do we can integrate 2D integration of the footprint. So what is the plan for 2D integration for the footprint? So now the footprints can be of three kinds here. So clearly you have rho, theta, phi. So what happens if you go rho first? So if you do rho first, you can have something along the lines of your rho will be fixed. Suppose rho is fixed to be 1. In this case, then you will get your region D of integration to be object of the following form. So this is your D, which is a phi theta footprint of it. And again, we are looking from the box perspective. All right. Now, next one could be theta first. So in that case, you basically take an angle theta fixed, and then you will get, if your angle theta is fixed for this half plane, then you look at the intersection, and then maybe you can get your region D. Let me use a different color. So your region D of integration when you do theta first. So it lies in that slice, right? Now the next one could be phi first. When you're doing phi first, the idea is you fix a phi, and then you are looking at essentially um, a region. So suppose if I take phi equals to 0, then I'm looking at a footprint of the following form. Yeah. If phi is not 0, then I'm looking along, say, a top of cylinder. So I have something of this form. Okay. All right. So now let's work through few problems so that the things become clearer. Use spherical coordinates to find out volume of the solid that lies above the cone square root of x squared plus y squared. So square root of x squared plus y squared is a cone of the following form, right? It's a big cone like that. And below what and below the sphere x squared plus y squared equals to r squared. So your cone is like that, and below the sphere, so this is your sphere, x squared plus y squared plus z squared equals to z. So essentially this sphere is x squared plus y squared plus z minus half the whole square equals to, so essentially so if you think about it, essentially a sphere with center half, and this is how the sphere looks like, right? So this is the completion of your sphere. Okay, so now question, how do we integrate this? So what are we trying to find? We are trying to find out the volume. So volume integral would be, you'll be integrating volume over region E of 1 dV, and that is going to be rho square sine phi d rho d theta d phi, and some reasonable permutation of this, right? Some permutation of this. So some permutation of this. Of course, this depends on which one we choose to go first. So in this case, we have many choices. We'll choose to go theta first. So theta first. In that case, your theta is between 0 and 2 pi. And then you take one slice like that for a fixed theta, right? And then let's see, what do we get in that case? So if you cut it a slice like this, you will get a shape of the following form. So there will be a shape of the following form here. So this will be my region D. So let me erase everything else so that D is clear to us. D. All right. So the footprint is region D. D doesn't look that pretty. I'll have to draw it properly. So let's just draw D properly. Yeah. Yeah. So this is how reasonable representation of my D is. Now, what are my sides in this case? So one side is essentially phi is, so I get, so top and bottom, we have already figured that out. Theta first, so top and bottom is 0 to 2 pi for theta. Now side, one side is rho is equal to, sorry, phi equals to what? So phi, in this case, if you take x square, z equals to square root of x square plus y square, we get what? We get rho cos phi equals to rho z is the square root of x square plus y square is rho sine phi, right? So we get, this implies sine phi. So we get phi, because this is r, right? And r is rho sine phi. So we get z, which is rho cos phi, equals to rho sine phi. This means phi equals to pi by 4. So one of the sides is phi equals to pi by 4. And what is our rho? So rho, to find out rho, let's look at, again, evaluate this equation. So we have x squared plus y squared plus z squared equals to z. So that is going to be rho square equals to rho. What is z? Z is same as rho cos phi. So this means we get rho equals to cos phi as the, so we get the next side is rho equals to cos phi. So we get two sides, no theta. So again, this is a validation. So this is for validation that whatever we have chosen to integrate first, in this case theta first, is a valid integration. Now for 2D, we need to come up with a 2D plan. So for 2D plan, we have, so 2D plan. So what we can do is we can have 2D plan. We can see that rho is between 0 and cos phi, and phi equals to, phi is less than, greater than equal to 0 and less than equal to pi by 4. So we'll do what? Phi last, right? So you can call it phi or phi. So therefore, the volume V is given by V equals to, now what are the limits of integration? So again, the first one is for 0 to 2 pi, for, so we are integrating 1, which is going to be rho square sine phi. So this is the volume element. Now first is, we are integrating with respect to theta first, so dou theta. Then the next we are going is for rho. So rho goes from 0 to cos phi d rho. And then we get d phi, which goes from 0 to pi by 4. So which we integrate, we can see to be the following. So I can just write 0 to 2 pi d theta. For rho, first I'll integrate with respect to rho. So rho gives me rho cube by 3, 0 to cos phi. And then I have, for phi goes from 0 to pi by 4 of d phi, and there is a sine phi there. So this becomes, so this is my volume V. So this becomes 2 pi. Now this is going to be 0 to pi by 4 of cos cube phi by 3 times sine phi d phi, and this can be seen as 2 pi by 3. Now if you let cos equals to u, you will get sine equals to, so cos cube is going to be, so this is going to be cos to the power 4 phi divided by 4, but with a minus sign, and we get 0 to pi by 4. So this is going to be 2 pi by 3 cos of, so cos was 1 by root 2, so it's going to be 1 by root 2 to the power 4, which is going to be 1 by 4, so 1 by 16, and minus, when you put 1, you get 1 by 4, so minus plus, and that would be, is going to be 2 pi by 3, so we add, so 4, so multiply top and bottom by 4, so minus 1 plus 4 divided by 16, and that is going to be 3 and 3 will cancel, so we get pi over 8. All right, so this is the setup. All right, so this solves the problem. Now so you can basically think about it in the following way. You took, so we took theta goes from 0 to 2 pi, so we took a theta slice first. Okay. Then we took a rho slice. Rho slice is what? Rho slice is, this goes from here to here. That means rho goes from 0 to this side, which is given by cos phi. And then we looked at phi. Phi goes from 0, the angle is 0, to 2 pi by 4. Now note that this, so homework, it's a good idea. Exercise, do phi first and theta first, if possible. Sorry, we already did theta first, right? So phi first and rho first. So do phi first and rho first, if possible. If possible, if possible. Okay. Now let's look at the following. So we want to integrate integral of x e to the power x squared plus y squared plus z squared dv, where e is a portion of unit ball x squared plus y squared plus z squared less than equal to 1 that lies in the first octant. So essentially, so this is the first, this is the top of the sphere. So we are essentially integrating so let me delete the back part. So this is what we are trying to find volume of this slice here. So in this case, what we have is we have x e to the power x squared plus y squared. So this, if you look at this guy, we have x squared plus y squared plus z squared. In this case, we have rho is between 0 and 1. Your theta goes from 0 to pi by 2, right? In the first octant, think about it, right? So in the first octant, we'll have, so this is positive x-axis. So we are in this first octant here. So your angle theta goes from 0 to pi by 2, and phi goes from 0 to pi by 2 as well. So this is spherical box, and we don't need these things then, right? I mean, you can still talk about the footprint and stuff, but we can directly write down for box, we don't really need to worry about the footprint. So this is going to be integral 0 to 1 for rho. So rho square sine phi d rho. So we can choose any order we want. So, and for theta is going to be 0 to pi by 2. So we have dou theta. And then we have for phi, we have 0 to pi by 2 as well. Okay. And then we are integrating x square, x here. So x, which is, so what is x? If you look at the formula up, x is going to be rho cos theta, which is, rho. So x was, if you recall, x is same as rho sine phi cos theta. So in this case, we can write it as rho sine phi cos theta e to the power x square plus y square plus z square is rho square. So e to the power rho square. So you can integrate that and you will get your answer. All right. So again, in this case, it's a box, so it doesn't matter which order of integration you choose. They will give you the same answer. All right. Now let's look at the next problem. Evaluate this integral v x squared dv, where v is a part of the ball, rho is less than equal to 4. So that means you have a sphere, rho is less than equal to 4. And between two cones, theta equals to 5 by 3. So 5 by theta equals to 5 by 3 is a cone, right? So that would be the inside cone, right? Because the phi is the angle with the positive direction of z axis. So if you look at here, so the first one will be pi by 3, and for the second one we have angle to be pi, this will be pi by 6, and this is pi by 3. So what are we looking at essentially? We are looking at a part of a sphere that lies between these two cones, right? So now we need to decide which one to do first, which one to go first for. So in this case, we can choose actually any one. So here, rho, we can choose rho goes from 0 to 4. So then the footprint, we're going rho first. So rho goes from 0 to 4. So in this case, we have footprint is going to be in region D. Now, how does our region D looks like? So region D will look like, so phi. So now the region D will be in phi theta plane. So bottom and top surface is essentially one of the, so bottom and surface is basically, so this is your bottom for rho, and top is 4 for rho. And now what about the sides? So sides are, first of all, one side is phi is going from, so we have two sides, right? So inside here. So one side is phi equals to 4. And phi equals to, phi equals to pi by 3 and right. So the inside one is pi by 6. So v equals to pi by 6. And the other one is v equals to pi by 4. My bad, pi by 3. So the outside one is pi by 3. And these are independent of rho, right? So yeah. And so the 2D footprint plan is, so 2D plan is, so your theta is between 0 and 2 pi again, right? So the projection, so theta is going to be, if you project any of these points, theta goes from 0 to 2 pi, your phi goes from 0, sorry, pi by 6 to pi by 3. So pi by 6 to pi by 3. So pi by 6 to pi by 3. So this is our 2D plan. So therefore we get this integral I will get, we are integrating x square, which is rho square sine square phi cos square phi, right? This is your x square. Then your volume element dv is given by, so now we'll write it in the order which one goes first. So we get d rho d theta and d phi. So theta goes from 0, so for rho goes from 0 to 4, theta goes from 0 to 2 pi, and phi goes from pi by 6 to pi by 3. And now if you notice there's some error made. What is the error? The error is that what is d rho? Sorry, dv. dv is rho square sine square phi. All right. So when you evaluate this integral, you get the integral you're looking for. You can in fact separate it because it's a rectangular box. Sorry, it's a spherical box. So you have 0 to 4. Let's collect rho square, rho square. So rho square d rho to the power 4 d rho. Now let's look at sine. So phi. So phi would be pi by 6 to pi by 3, pi by 6 to pi by 3, sine square, cos square. So we get sine to the power 4 pi. And then this is not cos square phi, this was cos square theta, right? Because x is, let me write down, x is rho sine phi cos theta, right? This was your r, so this is going to be cos square theta. So we get sine to the power 4 phi d phi, and the remaining is theta, so which is going to be 0 to 2 pi cos square theta d theta. Okay, so let's check. Rho square power 4 done. Sine square, so sine to the power 4 phi d phi, and then we have cos square is going to be this thing. So once you evaluate this, you get your integral. All right, so to summarize this lecture, we discussed about spherical coordinate system, and then we did integration in terms of spherical coordinates. and we described the different region, and we did 3 problems. All right. Okay. Thank you for your attention.